We are up and streaming. Yes. Alright. So tonight we are going to continue the SUB-10 repair. I was poking around with it a little bit and reviewing the schematics and watching the video from yesterday. So we're going to pick up where we left off. And where we left off is we were getting weirdness on the audio output. Let's fire up my scope here. We figured out that it was on the negative side of the output, but we really never figured out why. So I took the heatsink off, and I was poking around a little bit, and I did some measurements. I did them off camera. I measured basically everything on the schematic, checked for shorts, and that did not seem to be the problem. So I did a little more investigating and a little more looking, and luckily, you know, the schematics for these do exist. And I remember yesterday from the video after watching it that it seemed to be a missing return for the signal. So it was like almost like it was missing a ground. And one of the things that I stumbled on, and I remember from working on a few of these in the past, that the speakers are capacitively coupled to the plate. So, and I've had problems with those little traces that go to there before. And I just so happened to measure one of those traces. And they go to this one screw here. So if I'm looking at the positive, make sure my meter's on. I gotta get new batteries in the meter, but if I check positive to C73, I don't get continuity, which I thought was kind of odd. And if I check the other side of that to the plate, you know, the common plate earth ground, it's not earth grounded, but common plate ground, I have continuity there. Now if I check on the negative side, I have continuity to the cap, and I also have continuity to the plate through the cap. So it appears that the trace that goes to C73 from speaker plus is damaged. So I don't know if this for sure is the cause. Oh, my little dog's here. Hold on, we gotta take a break and say hi to my dog. She's crying. Hi, dog. Come here. Come here, say hi. Come here. Look at this awesome dog. How could you not love a creature like this? Come here, get up here. She says, I don't care that you're streaming online right now. Are you a good dog? I know you just want some love. That's all you want. You want love and a nap. The best freaking dog in the world. I know. You want a snack? Is that what you want? You want a snack? Alright, I gotta go give the dog a snack. So, give me a minute. I know I just started it, but, hold on here. Be right back. Family comes first, and dog is family. Alright, so sorry about that. Had to take care of my dog. But anyways, so yeah, I was probing around, and I thought it was a shorted output. It turned out not to be that. I didn't get any voltage feeding back to the op amp. And I probed around. I checked the diodes. Diodes were good. Checked the resistors. Those look good. Checked the pots. Um, so I was kind of stumped for a minute, and I did that off video because it's kind of boring just watching me check components. I don't think anybody needs to really watch me do that. But so I went back to the schematic and I looked around a little bit, and I saw that that's where the two speaker connections are. So I am thinking that something is wrong with this line going from speaker plus to the ground, and um, that is part of the return path for the negative side. So I'm going to clean that up, fix the trace. I couldn't find the broken trace. I looked, I couldn't see it. But what I'm going to do is I'm going to put a little jumper wire in there and wrap it around the leg of the terminal and then hit it on the other side of C73 and see if that brings it back to life. And so this is one of those like weird issues that it's really hard to chase. You have to check everything and then check it again, and even then, you still could come up short like I was. So it's a maddening issue when you run into something like this. So I'm going to check the trace too. I'm going to scrape the solder mask off and make sure the trace is making contact. I hope I have the right trace too. I think I do. But I'm going to clean that up and we'll see what happens. I'm hoping it fixes the issue because I really couldn't find anything else wrong with it. The amp was in fairly good shape. The wires for the speaker are going here, and they're probably flexing and vibrating, and these things are probably wobbling. It's possible. I mean, they're not loose, but it's possible it could have cracked the trace, or it's a factory defect, or I don't know. There's a million different things it could be, I guess, or a million different reasons. And now I have contact. Oh, and it went away. So weird. Oh, my meter died. I should have grabbed batteries while I was up there. Oh, let's do that real quick, because this is going to drive me nuts if I have to keep powering my meter back on for dead batteries. I love this meter. It's a Radio Shack special. I got it when they were going out of business in the local area. I have 2 of these. Oops, that's not where the battery goes. That's where the fuses go. But it's a true RMS meter. It's a really good meter. It's comparable to a Fluke, but it's just the Radio Shack branded version. Works great for what I use it for. I mean, if I thought I needed a better meter, I'd buy one, but I used the one model down from this for years and years, and I was so happy with it. I said, screw it, I'm just going to get the upgraded one, and we'll stick at that. Geez, these batteries are old. Kirkland, that's Sam's Club, right? It's an old set of batteries. Put some good batteries in there. So I guess I will be right back again. I'll give a few people a second to log into the chat, and we'll go from there. So let me go grab some batteries. Be right back again. Alright, so got some batteries. So hopefully that will alleviate that headache for the night. Except now I can't. Where's my screwdriver? Alright, so yeah, there's an intermittent connection issue somewhere between Speaker Plus and C73. And I don't quite know how or why it was there. Okay, so yeah, it's definitely a crack either in the solder joint or on the trace, because if I bend the tab just a little bit I don't get connection. If I push it back I do. So it's super subtle. So definitely an issue. I don't know if that's the cause of the problem. I'm going to assume that it is, just because they both share like a common grounding point, and it seemed to be a missing ground in the last video. So when I was playing around with the scope leads, so let's get this repaired and see what happens. And I'm probably only going to do this video tonight. Just the remaining part of this, and I'm actually off work tomorrow, so I will hopefully get a decent day in of doing some repairs. But I wanted to come back and try and knock this out tonight. One, because I said I would, and two, because I want to get it done. So we need to find a little piece of solid wire. And I think I'm going to steal it from a capacitor. That's a good spot to steal some wire from. Just because I usually clip the leads anyways, and I want it to be small and short. So I could just put a solder blob on there, but I feel like that would not be reliable. I want something that's definitely going to last. So, we'll go a little bit extreme with it. I'm going to make sure that when this thing's shaking, it's not going to, experience these problems again. I'm going to do a full wrap around, and I'll clip it and make sure it fits real nice in there. But this should solve the problem. At least I hope it solves the problem. Getting this thing tacked in there is going to be hard because I have no easy way to hold it. It's a problem with working with these like tiny little wires and circuits and stuff. Like, need teeny tiny little fingers. Oh, I hope that didn't go in my coffee. I bet it did. It sounded like it did. Oh well. A little bit of extra iron and some minerals. So it looks pretty good, and I'm going to clamp it in place by just pinching it. And that'll just make sure that it wants to stay once it gets soldered. I'm going to touch up both of these solder joints on here too. I'll do both tabs. But the traces that they have going to these are for the sense leads and for these two little I don't even know what you would call this. I guess it's just capacitively coupling them to ground. But there is no chassis ground because it's only a 2-prong plug on this, so floating ground, I guess? Isolated ground? but I'm pretty sure they reference each other, so that's the important part. The important part is that the signal relies on that. So it's good and soldered in. Now I'm just going to hit the other side of the tab. I'm doing it from the top, and I'll tell you why. If you get these tabs too hot and you solder them from the bottom, they just fall right out of the board, and it ends up being a pain. So it's easier to just, they have two legs on them, just do one leg at a time, heat them up to where you can get the solder to melt on the other side of the tab. And just, give it a second to cool. Let it solidify a little bit and then move to the other leg. That's the best way I've found to do it. And if they do end up moving, they just kind of flop over. They don't fall out. And you can put some heat in there. You don't need to be shy with the heat. If you don't think the solder joint's good enough, heat it up again. Let that solder flow. It'll wick down. It ain't gonna hurt nothing. You want to make, a good joint is more important than anything really. You want to make sure that when you plug these things in, they're plugged in. So, alright, we touched that up. I'll zoom in, give you a view of what it looks like, because it is kind of a tiny little rework here. Can I zoom in a little bit more? Yes. Oh, it's still got some. Camera's behaving today. Alright, that's all she got. So, you can see zoomed in, so here's the small little cap, which is kind of not showing up well on the camera. Oh, you can see it now. But I just took a little piece of wire and I went from the top pad of that cap across underneath the tab, and then just looped it around and pinched it and then soldered it in place. So now we have a good connection to the cap. The cap has a good connection to the grounding post here, and same with the negative side. So that, I checked continuity both to ground and to the terminal. So I think we'll have a good connection there, and we'll power it up and we'll see what the audio looks like. I think it should be better. Yeah, so everything is good on that front. And just for a sanity check, I'll throw just a little bit of solder on the other side of these caps, just to make sure if it is any vibration related stuff that we didn't overlook anything. Need more flux. It's not flowing on that side. It's like the ugliest solder joint I've ever made. It doesn't really matter, but I still want it to look nice. Alright, let's fire this thing up. I'm going to go through the silent speaker, and these are my bad ones. Let's put those aside. Silent speaker, and then we'll scope it out. I'm going to leave the heatsink off. We're not going to get too crazy with it. Once you take the heatsink off, you really can't screw it on until it's mounted to the plate. You want to make sure that when that bar is clamped, they're clamped at the proper height. Otherwise, you squish everything down and just makes a mess and puts a lot of stress on the leads. So you don't need it. I probably don't need big scope anymore. I can probably shut that off, but I'll leave it on for now just in case this does not solve the issue. And if the bias is out of whack, for me poking around these pots, I might need that to get the bias set back in. I don't have the bias adjustment procedures on here. I kind of just developed my own. I covered that in one of my videos, one of the early ones. But you basically put a 100 Hz signal in, turn the volume up to 50%, and then you look at the waveform on a scope and you adjust the pots until it starts to distort, and then you back it off until it cleans it up to almost perfect, and that seems to be the sweet spot. Whether or not that's close to the right way to do it, I don't know. I do not have the procedure. Alright. Everything should be hooked up. Let's turn my sound on. We're at 40 Hertz right now. That's good enough. We're going to go current limited. Let me make sure there's no metal or anything under here before I fire it on. I don't want to short anything out. What's going on, Michael? I think I found the issue with this. It appears that it was a missing ground reference. I don't know if the proper terminology for that is ground reference, because it's really not referenced to anything, but it's a common connection to the plate between the positive and negative through two capacitors, and that's right by the feedback. I found this on the block diagram. It's this down here, speaker plus and minus, both go through capacitors to the mounting hole. And then looking at these, you know, the feedback line for the pots, you know, is also connected to that same point. So, and here's our ground. I haven't checked to see if that's actually referenced to pin 3. I could probably look that up or do that right now before I power on. If it is, then that's definitely our issue. Oh, it's not right now. Oh yeah, okay, actually it is. So that is referenced through pin 3, and it goes through the plate. It goes through the screws, through the plate. So I'm going to say that's absolutely 100% what it is. King gay, your links are gay. Actually, you're not allowed to say that. Your links are lame. Stop putting porno links in my chat. Alright, let's fire this thing up and see what happens. I don't know where the volume's at. Let's see, top one's volume. So there's minimum. Alright, we're going to fire it on. Scope is hooked up. Hopefully you guys can see it. And the waveform still looks ugly. I'm going to hook it up to a speaker just in case the resistors are causing that. And I'm also going to put an alligator clip between these two. Actually, before I do that, let me alligator clip it first. Just make sure it's not missing the connection. I don't recall having to do that when I was testing other amps, but maybe it's a maybe on some models it's a requirement. There's a few different revisions of these, so it's kind of like almost anything can go. We're going to find out. So I'm just going to basically pretend like it's hooked up to the plate by just connecting these two posts together. And let's try that again. Volume's down, power on. And it still looks ridiculous. Alright, it ain't that. Unless there's more. Let's see, that's a plastic one. That's not ground referenced. It could be the resistors too. I'm gonna put it to the regular speaker and see what it actually sounds like, if it even makes any sound. I would like to also scope this, so I need a different connection. If that don't work, I have to say I'm stumped. We'll figure it out, but I don't know what else it could be. The op amp doesn't appear to be bad. And every time I've changed one of those, it ended up not being the issue, so I try to just leave those alone. How am I going to get that connected in there? That is the question. We're going to use this. My old speaker wire. And I don't know that having a speaker hooked up is going to make any difference at all. It's possible, though. It could. Sometimes these things do get a little sensitive with resistive loads. But I've tested these before, and like I said, I don't remember having any issues. The thing I don't want to get into is just blindly replacing parts, but I mean, sometimes you just have to do that. Something can be just like a slightly out of spec, and it just throws the whole thing off into the weeds. I could just replace the power supply too. I think I have some other power supplies laying around. That's cheating though. That's the easy way to do it. Alright, let's see what it looks like going through a speaker. We have no shorts. Oh yeah, that sounds terrible. Doesn't look good, doesn't sound good. Yikes. But we are getting sound, so I guess that's one step in the right direction. I'm going to play with the bias pots. I don't think that's going to have any effect on it. That one doesn't want to turn. These things, screwdrivers suck. And I don't have my adjuster, but this might work. So I'm not really getting anything on the scope that tells me that this is functioning properly. Now, let's see. This pot does make more of a difference. R4. R4 is that R or P? P4. So that's on the positive. 3 is on the negative. It's possible it could be out of bias. Nope. Alright, I'm going to go into the silent speaker because that is loud, and it's a lot easier to, let's see how hot these things are getting. I don't want to cook the amp either. That's another thing you got to be careful of. So it's definitely something in the actual circuit. So whatever's, let's see, so that's, I'm glad I didn't put all this stuff away. I would have been digging it all right back out. So it's not a missing ground reference. At least not where we found it. So it's got to be something in the circuit somewhere. P4 is the positive adjustment. That one seems to be doing stuff. P3 does not seem to be doing anything. And I'm going full swing. I mean, it's making a little bit of an adjustment, but not not like you'd expect it to be. So I'm going through and I'm checking the outputs one at a time. Don't touch both outputs. So I'm noticing Q14 is really hot. Q20 is okay. Q13 is okay. 19 is okay. Q14 is burning my fingers hot. So that's where my next point is going to be. Now I did check all these. I don't have a transistor tester. I need to buy one actually. But I checked them in diode mode and they all looked to be good. But maybe there's something wonky going with this output and that's causing the issue. So I turned these pots, so we're going to have to go through the bias adjustment. So I guess since I mentioned that, we're going to get to see it work anyways. Let's heat up the solder sucker and pull that output. You know, so testing components too, like it's somewhat rare, but you can have a component that tests good but doesn't function good in circuit. Now, I'm not sure that this is going to be the issue, but we know there's an issue at least with Q14 because it's getting hot. So I'm going to have to work my way back. So maybe Q11 is stuck on, or maybe it would be either 11 or 9 based on this schematic here. So if Q11 is stuck on, that means the gate would be full on and it would act weird. Or if Q9 was stuck on, you know, that would also cause it to behave weird. And the way to do this would be to plot that circuit and actually simulate it so you could see what's going on. But I'm not going to get into that tonight. I did it once a long time ago. I don't remember. I think I used like every circuit or something like that. It's like a free online thing, but really gives you a nice visual of what's going on there. And basically how this works is the audio comes in and it goes through these two diodes and it gives you half waveforms. So you get an upper half and a lower half, and then the positive and the negative are 180 degrees out of phase. So it adds the positive to the negative of the other one and the negative to the positive, and through that you get a sine wave. But the sine waves like get mismatched a little bit, and that's where these bias pots come in, so you can actually bring them back and put them right back in line. It's pretty cool how it works. Seems a little overly complicated. I don't know much about this circuit or who invented it or anything like that, but I think there's a lot of easier ways to drive an audio output. This is where my knowledge is limited. That's why this is a hobby. I can figure it out, but I can't really explain why. So we're heating up right now, so give me a minute to get the iron hot. Hopefully I think I have some of those outputs. I think it's it's either a Z14 or a 95. I hope it's not a 9530. I'll be out of those. I have 9540s. We'll find a part. Michael, you might be getting a used MOSFET in your outputs. I don't think you'll care though, as long as it works. At least I hope not. If you do, let me know. You have 5 seconds. Time's up. Alright, I'm draining the caps just to make sure I don't get zapped here or cause any shorts. So let's hope it's this output. And we'll test it out of circuit too after we pull it out to make sure that it's actually bad. So yeah, sometimes sometimes your hands can tell you you know what's going on and what's wrong. If you are gonna do that though, like you're doing that at your own risk, and you're gonna be extremely careful doing it because you can get a pretty good shock playing around with output voltage. No, I had the volume pretty low, so my rail voltage was probably only, you know, 10 to 15 volts. But it's still a good practice not to be reaching around and touching things. So that's my PSA for tonight. I'm troubleshooting and trying to figure out what's going on. And I'm having trouble isolating the problem. But we are finding multiple problems, so that's a good thing. So this is a Z14. I have those. It's an internal rectifier. I'm going to try and match them. If I don't have IRs, I'm going to give you a used one just so they're matched. Let's see what we got. That's ST micro, ST micro. ST micro. The 9Zs are IR. ST, I think all mine are ST, so I'm going to look at my donor plate and see if it's internal rectifier. If it is, I'll give you one of these just to keep them matched. It's a 9Z. What's this guy that I can't read? So if you can't read these devices, here's a trick. And, fresh out of Q-tips, but take a little thermal paste and rub it on the top of the device, and then when you wipe it off, you'll be able to read the numbers. Internal rectifier Z14. IRF Z14. So we got you a device. A matching one. Let's measure this just to see what's going on. I'm just going to do resistance between the pins. So I think it's gate source, then drain. So gate to source is reading open, gate to drain reads open, source to drain. They all read open, at least in that direction. Let's try the other direction. Throw it on diode check and do the same thing. And I have a chart that says what these should read in diode mode. So I'm not getting really anything off a gate. Let's flip them around. So this device does not appear to be functioning. So in circuit, you know, I got a reading on it, so I probably wasn't even reading this. I was probably reading the other diodes in the circuit. So we're one step closer. Maybe. I think I said that before. Maybe we're 2 steps closer now. Alright. Straighten these leads out a little bit. Yeah, from the factory, these leads were bent. You can see a side view of them. They were pretty crooked. That's because they put the clamp on before they put the heatsink down, and then when they screwed the heatsink down, it buckled the leads. It's that Chinese factory assembly. Alright, let's put our new and improved output in. I'm going to take the other one. Oh man, these all look a little bit. I'm going to see if I have one that has a little bit longer legs on it. It's not meeting my standards of flushness. And of course, they're all going to be cut. Striking out today. What is this here? Same thing. It's actually a good number 12. Oh, no, it ain't. This is one I was working on that somebody else tried to fix, severely damaged, so I'm trying to do all kinds of repairs on the bottom. Maybe I'll work on that tomorrow. That'll be a tomorrow project. See if we can get that sub-12 going. This guy is a little bit short compared to the rest, so I might just resolder them all in and tweak them so they're sitting at the height I want them to. That's one way to do it. Before I go through all that, though, I want to make sure the darn thing works. So let's see if changing the output makes it at least a little bit happier. Then we'll worry about making it pretty and functional. Alright, so let's hook up our little battery scope. We're still going into the silent speaker. There are no shorts. There's no metal. Alright, let's try again. Volume is at 0. Here we go. Nope. It's not output. Let's see if this one's getting hot again. He's getting hotter than his buddies. That could be because I messed with the biasing, but even if the bias is way, way, way off, it let's see, turn it up a little bit. Yeah, it's still not sounding right. Well, let's replace all the outputs. I'm kind of at a loss right now. That's the next step. We'll just put all new outputs in it, see if that changes it. Then we'll try to figure out which one was bad Power is off. We'll do a discharge. And we will take them all. I'm actually going to replace them one at a time. So we will, that'll give us a little bit better chance of identifying what's going on. So first one is a Z14, second one is a 9Z, and they alternate. I'm just kind of guessing the height right now. I assume these are going to need a little bit of tweaking when they're done. Try and get it as close as I can so I don't have to keep heating up the board and nuking the board. Of course, the second I touch the iron to it, it pulls it out of place. So I'm just gonna work my way down the line, swapping outputs, and then if that doesn't work, then I'm gonna go to swapping the gate drives. And if that don't work, then I'm gonna go to the diodes, and if that don't work, then I'm gonna take a sledgehammer and smash this thing and just give you a replacement amp. Maybe I'll smash it on video too, that might be fun. We'll be able to get it fixed. There's only so many things it can be. This should be a 9Z. That says Z. I thought they alternated. Let's see here. Q13 and 14. Okay, no, that is, they're both the same on the front side. It's a little bit tedious, but I want to make sure that everything's lined up. Get it lined up and looking good. There's no guarantee that this will actually solve any of the problems. But we're trying. Alright, let's see what happens now. We'll fire it up and then we will move on to the negative side. Still sounds absolutely terrible. Not it. Alright, let's try the other two. There's a good chance it's not the outputs. I got time. I'm off work tomorrow, so I can mess around with this and until I just can't do it anymore. Just verifying that these are what they're supposed to be. They're hard to read because they were covered with silicone. So this is a 9Z. And the other one should be a 9Z. I should have discharged there, but oh well. I didn't. Alright, let's try that one. Nope. One more to go. And then we start blaming diodes and gate drivers. There still is a chance it could be the op amp. I don't think it is, though. I don't even know how I could test that because it's in circuit. Like, I don't know. That would be a difficult one. Alright. It's probably not going to be this output. It's probably going to be a leaking diode in the bias adjustment section. That's my new assumption now. It's better, but not... I'm still getting nothing with this adjustment. It's very minimal effect, so it's got to be something that has to do with P3, which would be these diodes here, or Q9 or Q10. Q14 is getting hot. So Q14 is on this side, so I'm going to start with Q11. Q11 is our next next thing to try. Because in order for this guy to be getting hot, that means he's turned on longer than the other ones are. A signal comes in. What drives Q11? It can't go past... Well, the transistors are turned on from the power supplies. They're biased by that. Q11 is driven by this guy. So yeah, either Q11 or Q9. That's going to be the next place we go. So I will discharge this time, so I don't forget. And we'll start with Q11. There's only so many places that... You know, one thing I could do is I could take a measurement, a voltage measurement across the the pot and see what the voltage is. That would tell me if the diodes are not functioning. Because we should have, plus 15, minus 15 here, and then the voltage should drop as we're going across the diodes. So that's maybe one thing we can check. Compare that to another working amp. Supreme smash, yes, it might be. I don't think we're going to smash anything, but I think we're going to start with Q11. I should check between R87 and R90 to make sure I have 30 volts. That's kind of important. If I'm missing the voltage there, that could cause problems too. Let's bust out the meter here. Voltmeter. Let's put the scope aside for now, power that thing down. We're going to go by hearing, not by visual. So we're hunting for the bad component. And again, in circuit, it's extremely hard to find a bad component in circuit. We know like everything on this side of the board is working. The outputs have all been replaced, so it's not a blown output. I know the switch is working because we get variable voltage across our positive and negative rails, CD plus and CD minus. So now we're going to look for voltage, see what we got on our plus minus 15. So here's our ground, and there is our plus. You guys can't really see that. Let's see if I can prop it up a little bit. That's a little better. Somewhat visual. Alright, we're looking at R87, which is, I think, 2K. Where's R87? There's R88. R87's over here. Sorry for whacking the mic there. So between ground and that R87, I'm getting 2 volts on one side and 15 on the other. So we're dropping some voltage across that. Seems like a lot to be dropping. That's on the positive side. Let's look at the negative side. R89. Here's R89. So I'm getting -2, and this should be -15. So the voltage drop where's my -15? It's got to be there because I'm getting -2 on the other side. R89. Oops, that should be R90. My bad. My bad, wrong resistor. It is important that you choose the right resistor. R88, here's R90 over here. So we have -15 on one side, and on the other side of that, -2. So that seems to be going properly. So that means that the transistors are getting biased now. If I make an adjustment to P4, I should be able to watch those voltages change as I turn the pots. So that might tell us something. I need to find the other sheet so I know what resistors to look at. Alright, so the pot that works is P4. I am going to look at the low side of R104. Geez, I don't know where R104 is. R101, R102, R105. It's got to be this guy here. 2.2 and 15. Alright. So if I turn this pot, my voltage should change. And it does. Alright, so it's working on the positive side. On the negative side, we're going to look at R88. No, we're going to look at R87 on the low side. That is also adjusting. So the bias adjustments seem to be working properly. So we can kind of rule out that section. So that means we can either go to Q11, Q9, or our op amp is bad. Q11 drives Q14. Q14 is the one that is getting warm. So let's go there. Let's change out a transistor. Power is off. Alright. We are going to do Q11, this guy right here. There is no saving it. Oh, my razor is like a little bit too big. I wonder if I have a skinny one. Working tight spaces here. So I need a smaller blade. There we go. Don't try to unsolder these surface mount things. Cut them out and replace them. If you try to unsolder them or use hot air to pull them off, you're just going to wreck the board, and you might as well throw it out at that point. It's just not worth messing around. It's way more frustration than it's worth. And you can use, if you have a donor parts board, you can use donor parts to or hot air to pull the donors off. But the easiest way to take these out is just to cut the leads. Don't cut too hard because you'll cut right through the traces. This is the one, part of this that requires a little finesse. It's really hard to get the little leftover solder blobs on, or you can use wick. I don't like to use wick on these just because the risk of pulling up the pads is so high. But if you want to get it flat and ready to accept a new part, wick is the way to go. Just be gentle with it. Let the the heat do the work. Don't sit there and scrub the pad. Need some more Q-tips. I'm out of Q-tips. Alright, so we're going to start with Q11. I don't even know what Q11 is. I should probably look at it. I might have some new Q11s, so I don't have to dig into the donor stash. There it is. I probably won't be able to read it. Tiny little parts, way too small. So that is a Z6 MMBT 5401. ZE. I didn't know those were labeled ZE. This might be something else. I think I have those though. Let's look at my sacrificial plate. I want to make sure they're marked the same. And this one's marked C2. I am going to pull. Well, here, here, I'll show you how to look up surface mount parts. I don't think I've done that before. Let's pull up a Chrome tab. We'll go left screen. Chrome tab should be showing, I think. I hope. SMD codebook. There's a few of these. You just gotta kind of try and check a few different ones. This is the one I kind of like. We're looking for ZE, I think it was. ZE. MMBT 4123. That doesn't sound right. $54.01. That sounds a little better. What do they got on here? $54.01. So it is a $54.01. That's good. So that's how you use the code book. Let's go back to overhead. Alright. So I am going to see if I have any ones of those new. Surface mount transistors. Where are they? Here they are. I have 4401s, and what are these? I know I have those, I just don't know what package they're in. Here we go, 5401. Whole pack of them. $54.01. Just like triple checking that I'm using the right part. $54.01. So alright. I think we're good. So I don't think it's the op amp. I can't be 100% sure, but if it was just the op amp, the signal coming out of this would just be at like one constant state and there wouldn't really be any fluctuation on it. Unless it's just like kind of a questionable op amp. I really don't know. That's the last thing we're going to replace, put it that way. you can hot air these, but I prefer to hand solder them on these boards. If it was a different board, I probably would take the risk of doing hot air. But I want to make sure that it's on the board right and in the right location. I can't get enough twist on it. Hot air is a little bit more forgiving with the positioning than hand soldering, but hand soldering is safer for the board, so. Alright, Q11 has been replaced. Let's fire it back up and see what happens. And then we'll go from Q11 to Q9. And if that doesn't clean it up, then we'll have to continue digging a little bit. I don't think it's bias adjustment. Bias adjustment seems to be working properly. At this point, we got to figure out why Q14 is getting hot. I guess we could check R96 too to make sure that that value isn't bad. I doubt it though. Still sounds terrible. So it wasn't Q11. Could be D17. Tell you what, I'm gonna try and get a working board and get some voltages measured out, and I'm gonna start comparing, because otherwise I'm just gonna be popping parts in and out, in and out, in and out, in and out, and I really don't want to do that. This is beneficial to me to do it this way. I'll learn something. This is a RPW10, which uses the same exact amp, so I'm gonna fire this bad boy up. Same audio signal, same levels, and I'm gonna just pen on my sheet here some voltage measurements to see where we're supposed to be at. I don't think I have enough input length to run them side by side. Plus my desk is already just a mess of chaos and clutter. But we will find out where this issue lies. I am convinced we will figure it out. So we're gonna take this one out of the loop. What I'm going to do is let's see, how do I want to do this? I'm going to use the same input so nothing changes. And that'll give me some rough voltage ideas of where we should be at. Give me a second, I gotta wrap my cord back up here so I don't make a mess. And when the components are in circuit like this, like there's almost no way to, you know, find out exactly what's causing the problem. you either got to replace parts and get lucky, or take some measurements and figure it out. So I'm going to zoom out here. And I need to get like a little notepad. But this is the same exact power supply. It uses the same exact input connection. So I can just unplug this guy from here. And I'm just going to do voltage measurements and see where that gets me. Even if it is a an audio signal, I should still be able to get like an RMS voltage level. That should at least kind of point me in the right direction. I'm gonna go grab a little notepad. I will be right back. Alright. So I got a notepad. I'm going to take some measurements. And I'm just going to go part by part on the entire negative output side. Because it seems like this adjustment pot is what's not working. I'm going to adjust it to the same value that this one is in ohms. And then we're going to take some readouts and just jump back and forth and compare them. It should be pretty close. Of course, I can't get to the legs on that easily because they're covered in glue. Let's see, we want to go between the wiper and I guess any leg. Alright, that one's reading dead short, so it's the other leg we gotta measure. 259 ohms. So between here and we want 259. We're at 315. Too far. And I'm not going to be able to get it like right on the money, because these things are like super sensitive. Close enough, 259.7. Let's see what our other guy is. 267.5. He's at 325. So we'll drop him down to 267.5. Oh wow, I got lucky there. That was super luck. Alright. Now we're going to take some measurements. We're going to go... Let's see, what's the best way to do this? I gotta switch the speaker back and forth between the two when I do that, and the input board and the power. I'll be doing a lot of messing around here. It's gonna drive me nuts if I don't figure out why this thing isn't working though, so I'm like, I won't be able to sleep. And I got a whole pot of coffee, so I can just keep slamming that until we get some results here. Alright, let's hook up power. I don't know which pin is which on the oh, you gotta be kidding me. Wires are all tangled. They gotta come out anyways. I don't know which pin is which on the transistors, like which one's base, which one's emitter, which one's collector, so I'm just gonna draw out the shape and I'm gonna write the voltage that way. There's no I don't want to look up the data sheet for each one of these parts. It would take too long, and I don't really think it's that important. I am going to insulate one of my speaker leads though to make sure we don't get a short. Just throw a little painter's tape on there. That should be fine. Alright, all these are going to be referenced to ground, which should be our plate. Yeah, which also should be that guy, so I can just stick my probe right in there, and we're going to start. Let's see, we're going to do Q11 and Q9, and then I'll also do pin 1. So Q11, that goes like this. Q9 is 2 below it, same direction. Q9. Alright, let's see what those two give me, and then we'll go back to the other board and compare. I think I can power on this one. Should come up. No. What did I do wrong here? We have power. We have input. Did I turn the volume all the way down? Yep. So I'm getting audio, so I'm gonna just pick a position. That'll probably be really annoying when I go to the other side, but alright, let's see what we get here. .94. We'll call that 0.94 volts on the top. Doesn't have to be like deadly accurate. .89 on the left, 12.88. And on the right, .51. And again, we're just doing this because I don't want to pull all these parts out of circuit to try and figure out which one's bad, and I just don't want to replace everything on the board because then I'm not really learning where the problem was. So by comparing a known good to a known bad, I should be able to isolate at least further in where the issue is. This one is mounted to a plate. I don't think mounting it to the plate is going to matter that much. I know I've ran these out of plate before. And I could put my SUB-12 plate in there just to check and verify that. That would be the only difference between the two. And I can put that, I'll put the alligator clip back in just for the sake of sanity. So that ensures that those two are connected together. Alright, let's go to Q9 on the top. Got 12.9 volts. Again, these measurements are irrelevant to anything that anybody else will be doing. Because this all varies on, you know, what your pots are set at, what your volume and inputs are set at. And we're just trying to locate what the problem is on our other amp. 2.16 on the left. I'm sure somebody that like really understands electronic circuits could just look at the waveform and be like, oh yeah, it's this part right here. I hope to get there someday. 1.56 on the right. But for me, this is how I can do it. You know, I'm walking through the various parts of the circuit, and so by doing that, I'm getting, you know, I know this is hard to see. This is kind of off camera, but by getting these measurements, I'm reading the voltage is coming through that resistor, so I'm kind of, you know, making sure that this resistor is good. I'm getting the voltage through this resistor and diode on this pin, so that's telling me that these two parts are functioning properly. When I measure the gate on this one, that's measuring this resistor here. So I'm getting a lot of good measurements on all sides. When I measure this pin, I'm getting the output of the op amp. So if this number is something totally weird, then I know, you know, it's something that's affecting the op amp. So it could be something on the bottom part of the circuit. So I'm going to get pin 1, which is our output. Just get a reference there. I don't know if you know, it's a critical voltage or not. .7 millivolts. It seems low for, I mean, we're measuring DC too, so keep that in mind. But we have DC coming in through here and audio, which is pretty much AC coming in through here, so I don't know if the measurement on pin 1 is accurate. I guess we're getting like a DC component that's in with the let's do AC on the op amp. Just because 231 millivolts AC. That way we have both. Alright, let's shut that down. Then we'll go over to this guy. Take the same measurements and see what's close, what's way off, what's probably identical. I hope not, but it's possible. Now there might be some subtle differences because the voltage regulators are going to be putting out different voltages. They're not going to be exactly the same. So there is going to be a little bit different, but I'm looking for stuff that's like crazy out of line with the other one. That doesn't mean I'm going to find anything that's crazy, but I'm hoping this will help hone us in a little bit. Alright, everything is hooked up. Let's go back to DC. We should be able to fire this up. It sounds terrible. So I'm only getting half the output on the top of Q11. I am getting 12.8 there. $13.5, 12.9, 2.1, that's close enough, 1.485. So the biggest discrepancy is at the output on the top of Q11. It's about half. I apologize for that horrible buzzing sound. I should have did this with silent speaker. So the top of Q11 is the biggest problem. I'm only getting half. Not even, I'm getting a third of what I need. I need to find out what that is. I gotta look at the data sheet for that. I gotta see if that's the gate. That way I know where it is in circuit. MMBZ5401. 5401. I probably won't be able to find it. Transistors bipolar. Surface mount. MMBT, not BZ. Of course, they don't put it on the first page. Why would they? That's pin 3. Pin 3 is the top one, and pin 3 is collector. So pin 3 is what drives Q14. And that is the one where I'm getting half the voltage. So that tells me that it could be an issue with CD minus, or it could be the two resistors that are associated with Q14. Let's continue. I think I scared the other watcher off with the loud buzzing. Was that sound like crazy annoying? I'll switch over to silent speaker if that's the case. I'm surprised my wife wasn't screaming. It was loud in my ear, so it had to be loud over the microphone. So R95 and R96 are my next two things to check. Power's off. Let's go to ohms and check R95 and 96. 22 ohms, that's what that one should be. Or 96. 0.823K, I think that's correct also. $8.25. Just for verification, we'll check on this guy. $22. $20.827K. So the resistors aren't bad. What the hell is causing this thing not to work? P3 does not seem to be functioning. Alright, let's check R88 and R89. 3.92K. That's also got capacitors by it. Maybe them capacitors went bad. R87, there's R89. It's going to take a second to come up because it's got to charge them. 3.1K, that's close enough. Where's the other one? R88. So it's not the two resistors, it's not these two guys. That means these two capacitors are still probably good. We still got to check these diodes. If I take the feedback out, I lose the... I think the op amp becomes unstable, so I can't do that. I know we have good signal on this point here going into the op amp. We have bad signal on the resistor that's connected to the op amp, so I'm gonna, just for the heck of it, check the resistance on the op amp pins. So between 1 and 2 I have 6 meg. 1 and 3 I have 6 meg. 2 and 3. I have 72K. Let's see what we get on this one. 6 meg. 6 meg. And right around 70-ish K. I want to say that the op amp is behaving properly. That leaves us with Q9. I guess we can just start checking resistances and looking for resistance anomalies. Measure Q9. I don't know where we're going to learn from that, but we can just check. 2.9 meg with red on top, black on right. I mean, we're in the mega ohm range, so it's not really gonna teach us much. Get nothing between left leg and top. Let's see, left and right. .8 meg. Doesn't appear to be Q9. Put the black lead on top. 10 meg. 1.89 meg. Meg 2.0. So Q9 is probably functioning properly. We already replaced Q11. Let's check Q10. You know damn well what's going to happen. It's going to end up being the op amp, because that's the last thing I said I was going to replace. That's like Murphy's Law. So Q10, we got 1.9. And open. 1.8, which is close enough. And open. Let's switch the leads. 6.7. And open. $7.8. Open. I'm going to say Q10's probably good. Where's the other one? Q12. All the way on the top. It's going to turn out to be a broken trace on the board is what's going to happen. I have to do continuity checks. I never thought about that. It could be a bad connection somewhere. 12.7. 2.1.9. 1.8. That one's going way down. So Q12's giving me 8K on this one. I'll have to remeasure that. 1.98. Let's check that again. Q12. It's behaving the same. 14, 13, 12.9K. This one is going much lower, but Q12 reads about 8K on this one. Let's see what it reads extended on this one if I hold it on there. So there's about a 4K difference between Q12. I don't know if that's enough to warrant digging any further into. But there is a discrepancy there. Let's try a different measurement on Q12. Let's go bottom 2. Right on top of the right pin. .8 meg with black on top on Q12. 2.0. Q12 is acting a little different, so we got to look at everything that's around Q12. The good plate's reading about 12.8K. The bad plate is reading once it finally starts counting down, it goes down to about 8. $4K difference is pretty considerable. So something maybe around Q12 is not behaving properly. We're going to look at R92. I don't think that's going to be an issue, but we're going to check it. The nice thing about having a known working plate is when you're measuring in circuit, the numbers should match. Even if the values aren't right, the numbers should match. So it's not that. Q12 also connects to R93 and 94, so we got to check those. So we did 92, then we check 93 and 4. And those are by this device here. .22, that's good, and this should be .8 something. .825, which is what it is supposed to be. 825 ohms. So it's not that. Maybe Q12 is acting weird. Let's check our diodes. D22 and D17. The other thing that I can do that we talked about doing is sistering these circuits together. So taking the signal from a known good point on here, feeding it into this, or from this amp plate to the good amp plate, and then checking to see what we get on the speaker minus and see if we get the missing part of the sound. And just bypass the whole circuit. But we know this is good, so that would actually work. We would have to actually look at it outside of or out of the op amp. Let's see, let's check D17. D17, pin 1 and 3. Should be about a half a volt if I find the right pin. So that, I mean, that diode looks good. D17 looks good. Let's check D22. 17, 23, 24, 21, 22. Diodes look good. Let's ohm it out. That's the next step. See if we have a broken trace. This is hella boring, but I'm kind of drawn at straws there. Pin number 1 connects to R84. I'm just going to ohm through the entire circuit just to make sure there's no broken connections. 89, 88, 80. There's R84. The other side of R84 connects to Q9. So that's good. That's pin 2. Pin 1 goes to D18. That's good. Pin 3, which is the top, goes to D17. That's good. Which goes to R83. D17 goes to R83. The other side of R83 goes to... Why did my meter just shut off? There are brand new batteries in there. Goes to plus 15 volts. So that part of the circuit is connected properly. Plus 15 goes to R87. Yes, the other side of R87 should go to R88. The other side of R88 goes to speaker minus. That's good. So we checked that. We'll check the bias circuit because the bias is what seems to not be working properly. So we'll run through 18, 19, 20, and 21 and make sure that that's behaving. I mean, we were getting a voltage adjustment though, so I want to think that it's working properly. I am freaking stumped. Oh, let's check it anyways. Let's make sure these are all connected. Let's see, the bias point is on these two transistors. Well, let's check Q9 pin 1 and see if it goes to D18. Q9 pin 1. Yes, that goes to D18. D18 should go to D19. Which it does. D19 should then go to D20. Where the heck is D20? 23, D22, 27, just 20 over here. Yep. 20 goes to the pot. The front side of the pot should go to D21, which it does. D21 should go to Q10. Everything appears to be connected, so it's not a connection issue. I really don't think it's the op amp. And I'm terrified to cut that thing out because I've damaged so many of those things. And if I damage it, the board is done. I don't know what else it could be. We've checked pretty much everything in the circuit. The bias adjustments are working, but it's not affecting the output. At least not on speaker minus. The odds of that being bad are so slim. Well, maybe we'll try it. Like I said, if I wreck this amp, I'll give you one for free. I don't care. I just can't seem to think what else it would be. We fixed the intermittent grounding issue. Just for a little bit of my sanity, let's see what else is connected to plate ground. So H13 and 14 goes to CD+. That's this guy here. So we have that bridge together already, so that's not the issue. We connect to ground, and then it's capacitively connected to CD+ over here. Not the issue. It's not a missing ground. Yeah, it's not the ground because I'm looking at the where the grounding points are. There's only 3 that are connected. So H4, which goes to the speaker terminals, which is this guy here, and I have an alligator clip on him. And then the other place where it connects is 13 and 14, which is here, and I believe those are hardwired on the plate. So if I go between here and here, yeah, so those are connected. So having this alligator clip on there simulates the plate being on the back. It's not the plate. It's kind of pointing to the op amp right now. We did have one output that I believe it was this one. Let's see. It was either this one or this one. Which one is this? Is this a Z14? I didn't wipe that one off, so let's get a good Z14. I know we got another one here somewhere. I pulled it out. So going between the first 2 pins, oh, we gotta be in diode mode. And you really can only get an idea of what's going on. So that's open. Open. 0.556. So if I do the same thing on this guy, 0.556. Flip the leads. I don't know that I'm measuring the right one either. Alright, so that's a little interesting. There is a little bit of leakage on that. There might be the same thing on here. So there's not. So one of the outputs was definitely a little bit weird. If I go to drain and source, I get 0.036 of a volt of leakage. And if that was this first one here, Q14, and I think Q14 is gate drain and source. So that could have came back and hit the op amp. It's highly unlikely though. I mean, there's a pretty large resistor here. Oh, I guess we can swap the op amp, right? Let's swap it and see what happens. I think my donor plate has one. That one looks a little gnarly. I might have a new one. Let's see. Do I have op amps? I thought I did. I do. I have some. That's a JFET. That's not the right one. That's not the right one. Of course, I don't have the right one. I think I have a couple left in this box here that have not been destroyed. That's a 324. That's no good. This one's been soldered in once before. I have no idea if that one's good. I have two that I've used before. They're new, but I've used them, so I don't know if they're good. I'm kind of hesitant to swap those out right now. How do I check that? There's really no easy way to do it. And I need to pull that off. Well, I guess I can just swap it out and we'll see what happens. Worst case scenario is it doesn't work, right? It's not like we'll be any further off than we are now. I did say though that it's probably going to be the last thing that we do, so if we swap it and it works, I'm not going to say I'm surprised. Just it doesn't seem like it would be a bad op amp, and these things generally don't go bad. That's what makes it weird, but that doesn't mean they can't go bad. They just generally don't go bad. I'm going to try and use my surface mount tweezers to do a hack job and pull this off without wrecking it. I don't want to use hot air if I don't have to. So I'm just blobbing solder on there to get enough on all the pins to where I can hopefully get it hot enough to pull it off. It's a trick of the trade. You risk damaging the part, but you don't risk really damaging the board. And I care more about damaging the board than damaging the part. If it's not the op amp, I'm just going to start swapping part by part until we figure out what the heck it is. That's like the terrible tech way to do it, but I think when you're this far stumped, you got to try something out. I'm gonna get the solder sucker and clean up these pads and put the new FET on there, or the new op amp, and we'll try that. See what happens. I had one other plate that acted similar to this, and I never did find the issue. I never went as far as replacing, you know, all the parts in the segment of a circuit. I just kind of gave up and said, you know what, this thing sucks and it's not going to work. But it would be really interesting. I still have that board in my junkyard box. It'd be interesting to find out what's going on with this and see if it's the exact same problem on that. That would at least give me a data point to try and figure that out. Do a little bit of braid on here just to smooth this out and then clean it up. I'll be thrilled if it's the op amp, because it was definitely not the op amp on the other one. And I remember that because I actually cut that one off the board and replaced it. And it did exactly the same thing. I need somebody, maybe I'll take this circuit into work and talk to one of the electrical engineers and have them teach me exactly, you know, what I should be looking for and how this operates a little more in detail. I mean, I know the basics of it, but I don't know the reasons why they did it this way. Somebody with 30 years experience with circuits should be able to look at it and pretty easily tell me what's going on. Although that's not always the case. I've worked with a few engineers that had no clue what the heck they were doing. Alright, we gotta solder the new-ish op amp in there. Little microscopic pads. It's like doing surgery. I'm going to change my tip to the fine point. I don't want to wreck this thing. Where are my soldering tips? I haven't used those in a while. Solder them in with the fine tip and we'll clean them up with the big tip. I just want to make sure we get them soldered down without pulling too much heat into them. Without bridging them. That almost looks factory. Once I clean it up, it'll be hard to tell. Alright. We put the op amp in there. Let's see what happens. It might work, it might not. Like I said, failed op amps on the actual amplifier board is extremely rare. Maybe when I first started out, I was always replacing those, and it really didn't make a difference. This distorted audio thing on this is also a pretty rare symptom. And I've experienced it once before, like I've said, and I never did find out what was causing it. Alright, we have speaker hooked up, we have our ground plate hooked up, power is going in, audio is going in. Let's see what happens, see what it sounds like. Nope, ain't the op amp. I figured as much. I figured it is not the op amp. It sounds exactly the same. Let's take another measurement of this potentiometer. So that appears to be working. Where are we missing our signal from? Time to bust out the scope. Multimeter is not working for us. I'm going to clean up the desk a little bit too, because it's just an absolute disaster right now. And I'm going to have to go to silent speaker, because wife is gonna wig if I keep making buzzing sounds like that. Wig is an understatement. She's just gonna have a meltdown. I don't know what I touched, but it poked me. I love painter's tape. Good stuff. Comes right off. Alright. Put my audio cables away. Put some of my tools away. Get a little organized and we will make a new mess. So we know where the problem is, we just don't know what the problem is yet. And where it's, you know, coming from. And the hard part is there's so many different components in this feedback loop of this op amp. It's hard to you know, figure out what's going on. It's not like it's a, you know, a gain stage or a filter stage. That would be real easy to figure out what's going on because, you know, there's very few components. This is much different, so it's a lot harder to diagnose and actually figure out what's going on. We'll throw that back in the junkyard for now. We don't need that. We do need our scope probes. And since we share common ground, I believe that's common ground. Pretty sure it is. We will verify. Yeah. So the voltage regulator, the tab on the voltage regulator that's closest to the transformer is audio ground. I'm just going to hook my blue probe up to it just so I have ground reference. Let's get this other plate out of here. We don't need that in the way. And we're just going to probe this whole circuit again and see if we can try to isolate where this anomaly is lying. And I'm actually going to look at both sides this time. I'm going to look at the positive and the negative. Let me adjust the camera. Alright, get this light out of the way. So, actually turn it off. What can I prop this up with? Let's throw some Legos behind there. Legos are always good for stuff like that. Alright. We're going to hook silent speaker up. And I'm going to rely on the scope to give me the waveforms. I'm not going to crank the volume up too high because I really don't want to screw anything up here. I am going to get my 2 output stage schematic sheets so I can follow those. Without these schematic sheets, this amp would not be fixed, so at least not by me, it would not be fixable. I just, following these circuits is hard enough with the sheets. So we know one side works, and we know one side doesn't. And I know we're not getting a good audio signal coming into the op amp, so garbage in is going to be garbage out. But we should be able to look at what's coming in versus what's going out and identify at least what side it's on. Is it on the top side? Is it on the bottom side? So let's try to do that. Speaker plus, I believe, is working. That's pin 7. Did I lose my probe already? No, I buried it. So we'll start with pin 7 and make sure pin 7's good. Scope is running. Alright, I'm gonna kick power on. We're in silent speaker right now. And I'm getting nothing out. Why am I getting... Oh, because I'm looking at channel 2. I want channel 1. $5 we can dial that way down. So low volumes it looks okay. When you go to higher volumes it starts to freak. That's actually clipping. I don't know why that's... That should not be clipping. Is that the preamp? What the heck is going on here? Side 7 was the good side, or pin 7. That could be my preamp acting weird too. I'm going to trigger on channel 1 just so I get a smooth wave. I don't know why that's peaking out. That should... I think my preamp is behaving weird. Let's see what's coming out of pin 1. Pin 1 is nowhere near what pin 7 is, but it doesn't look weird like it did. But I'm not getting any gain on it, so I'm getting good gain on pin 7. Pin 1 I'm not getting any gain on. It's just very muted. I gotta keep checking these. I don't want to burn the outputs up. Well, let's go through this and look at so we know on pin 7 we're getting a... hold on, I can't look at that. That's a bad signal. I want to get a better preamp in here. I think it's my preamp that's making it look weird. Maybe not. Let's try a different one just to rule that out. This plate's out of a SUB-10, but it shouldn't matter. It should still do the same thing. Let's see here. It goes this way. I just want to rule out that something else isn't going on. That op amp could be damaged too. I don't know. It was a used op amp. I can probably put the original one back in. Let's see. I don't think we need these on here anymore. That doesn't really matter. Alright, so top ones are volume. I just want to verify that I either screwed up the op amp or put a bad op amp in there, or something else is going on. Power is on, right? I have my ground. Let's see what we're getting here. Yep, power's on. I'm plugged in. I'm getting... oh, I don't have audio going into it. Can't get anything out if you don't have anything going in. Brain fart. Try again. Get them comments out of there. Remove. Alright. Let's get back in here and get some audio. So it's still clipping off. Really bad. So I think this op amp's bad. I gotta put the other one back in, but drawing a lot of current there. We lit the light bulb up. Interesting thing is now channel 1 looks better, and channel 7 looks weird. So maybe it is an op amp issue. I'm going to turn the voltage down so we can get a better look at the waveform. And I'm going to crank up channel 1. Oh no, see, it still looks funky. Let's turn channel 2 off. There's still a gap in there. I might be able to adjust that out. This thing's going to start getting hot. I have to work somewhat quickly. Yeah, outputs are starting to get a little toasty. They'll cool off, you know, if I turn the volume down to 0 and let it chill for a minute. Channel 1 actually cleaned up. I mean, at the higher levels, it freaks out a little bit, but when I turn the volume up, I can tune that out. Like, you can see the gap in there. Well, maybe not. I can almost tune it out. Yeah, so now the other pot's not making any adjustments. This darn thing. It does look better though. It looks a hell of a lot better. I don't know what's going on with the other side though. The other side is just hosed. I mean, it's way off in the middle of nowhere. Alright, I gotta shut this down. I'm gonna say that op amp is probably bad. So what I'm gonna do is switch it out again with another one. And see what happens. So the one that we took out, we know is acting funny. I'm gonna pull one off of a donor plate. I would like to verify that the preamp is behaving though. My preamp. I've blown that thing up before, so I'm a little weird. Yeah, I don't trust it because I've blown it before. Testing, trying to solve problems. But let's see if the waveforms look the same using my little tester one versus using the one on that SUB-12 plate. If I still get a bunch of garbage on the channel that used to be good, then I will know that it's an op-amp issue and not something that is caused by the input or anything else that I did. Bias is way off in the weeds. I'm going to dial that back. At least get them close to center. Alright, power on. All this is being done current limited too. Oops, hold on, we need our audio lines. All this messing around for an op amp. So channel, and this one at low volumes it looks alright, but it just, the waveform just goes way the heck up into space there and doesn't look right. That doesn't really look right either. Well, I'm going to change the op amp again. Like I said, this one, there's a good chance that this one's been damaged. I put it in something, took it out again. It's, I can't say that it's good, so it's going to come out. I can't say that the original one is good either. I unfortunately don't have any new ones of those. I will add it to my shopping list. But I don't have any right now, so my options are kind of limited on what I can do. So what I will do is I will find one on one of my plates that's in my little heap here. And I will pop it off and do a transplant. And hopefully the one that I pull off will be good. Or at least take us back to the original behavior. If we get back to where we started, then at least we have a valid data point. There's always risk pulling parts off of boards though. Like if you use hot air, you risk damaging them. If you use the tweezer method, you risk overheating them. Like there's really no free lunch when you're doing this. Best thing to do would just be to buy some new parts. This one looks like it's had one already in it. I don't know if I'm going to be able to get this one out. This one doesn't. I'm going to look for another one. This one doesn't look too great. Let's see, I know I have more boards in here. This one has not been pulled off, and this board is garbage, I believe. Yeah, it's missing a bunch of parts. Missing a bunch of parts, but it has the original op amp. That by no means it's good, but the reason I'm like pre-soldering it is I want to get lead on there because the lead's a lot easier to melt than this lead-free crap that's been on there for who knows how long. It thermally stresses the part a little bit more, but that's like the give and take. So this is the one that we are pretty sure is bad. We'll put that to the side. I don't get to use my tweezers very often, so that, I guess, is kind of cool. Alright, thank you, donor. You may now go back to your scrap pile. I say we probably got 2 more shots at putting something on these pads before the pads lift off. So I'm going to be a little ginger with it. Hopefully this op amp's okay. I don't know if it's going to solve the problem, but maybe it'll tell us something. It's weird that the issue seemed to switch sides, though. That tells me that maybe we're on the right path. Alright. Can't see where pin 1 is on this thing. Some of these don't have markings on them. They just have like a little chamfer on the one side. I'm pretty sure the chamfer marks pin 1, so we're going to put it in like that and say that's correct. I should probably change to my pointy tip too. That should be alright. Alright, get it lined up. Get this guy soldered in. And then we'll see what happens. Just bridging pins left and right here. Have to use the bigger iron to fix that. Alright. The replacement of the replacement is in. I think it's in the right orientation. I'm going to verify that. I need to look it up. Probably put it in backwards. TL084. Linear amplifiers, instrumentation, Texas Instruments. Actually, this is an ST. ST Micro. It's an SO14. Yeah, pin 1 is marked by like the little ramp. So I believe we have it installed correctly. If it's backwards, it's just going to start smoking, so we're going to find out real quick either way. Alright, let's try again. Get the metal out of the way, get the solder out of the way. I'm just going to use my yellow probe and ground. Alright, silent speakers hooked up. We need audio input. And we will check pin 7 first this time. Alright, here we go. Power on. Pin 7 is back to normal. That looks nice. It's a little wobbly because my finger is like right there touching it. Let's check pin. Yeah, we're back to where we were. We've made no headroom or no improvement. I don't know why that's, well, that's probably clipping because the other side isn't functioning properly. Oh, this is maddening. Let's go back to R98. That's where our audio signal comes in. Just verify that at least we're looking good up to that point still. Excluding the op amp. We gotta take our voltage way down here. So we get sine wave on that side. I don't know what we get on that side. Make sure I didn't switch my probe to 10x. No, we're on 1x. I thought it was a higher R98. I thought we got a higher voltage than we're actually seeing. There's my trigger. I mean, so we're getting signal coming in. Doesn't look that great. R98 is the side that was good. Let's check speaker minus here, R81. R91. R82. Where is R81? I know it's here somewhere, I've seen it. There's R80, 93. '84, '87, '83, '91. 85, 86. I can't find this damn resistor. R82. Where does that go into? That goes in the pin. So it's got to be this guy right here. What is that? R80? 10K. Yeah, that's this guy right here. So same thing. Decent waveform on one side. On the other side, I get nothing. So even with the volume all the way down, I'm still getting signal into pin 7, or out of pin 7. So if I go to the gate of Q17, which I don't really know what let's see, that's Q17. The gate should be the one that connects to Q15 and D23. So it's this one. Well, that one connects to 108 as well. That's not it. Turn our voltage up so I can see what the heck's going on here. 5 volts, Q17. We should get half the waveform. Which we do. It freaks out on us and flattens out, but yeah, there's part of the waveform. Now if we go to Q18, we should get the top half, which we are not getting. Oh, there it is. So we have a positive component. And over here we have a negative component. That's what it should be doing. Even though it's a little bit distorted, but it's going to be a little bit distorted because we, let's see what we got coming out of Speaker Plus. Nothing but distortion. Looks terrible. Absolutely terrible. And I'm not even getting Q14 still getting screaming hot. More so than the rest of them. So we still have an issue with this somewhere. If I look on R80, which is the signal that's going to be coming into this, it's probably going to look pretty good. Let's turn our voltage down. Let's go way down. Position at 0. So, I mean, we're getting a good signal in. It's tracking with the volume. It's once we get to R81, which I believe is this guy over here. Signal and nothing. Let's turn the voltage way down. See if we can get something on there. It's just garbage. What are the chances that R81 is bad? Slim to none, but we can check it. I believe I checked this already once too. I don't think it's this resistor. It's definitely something else. Oops. We need to be in ohms. Yeah, R81's good. R81 is good. What is causing our feedback on this side of the circuit to freak out? Let's go through every resistor. At least everyone that we can properly identify. So we know 81 is good. 84 and 85 should be 511 ohms. Or let's do 83. 83, 84, 85, 86. Here's 83. 510. Here's 84. 515, close enough. R85. 510, R86. 509. So it ain't one of those. Let's check 87 again. I'm just doing sanity checks at, you know, at this point, because I don't know what else to do. R87 is showing 1.78K. R90 should also be close to that. .78 Okay, so that's good. 88 and 89 should be 3.92. Okay. Here's 88, 89. Let's see what we got. 3.12. And again, it's in circuit, so you got to give a little bit of deviation. 3.12. I mean, they're pretty. 3.13. They're pretty closely matched. So those are good. R91. Where is R91? R91, where are you? 332, that one's good. R92 should also be 332. Which is this guy here. $332. R90. And we checked all these ones up here. The 825 ohm and the 22 ohm. I know those are good. We put new outputs in. Let's just verify that those are in the right spot, I guess. 13 is a 9Z14. This shows 9530. Those are compatible. And this one is Z14. So our devices are in the right spots. That's not the problem. There's a weird spot on the board over here by the bash board, but I don't really see any problems with the bash circuit. But there's a resistor that looks a little toasty, R60. 2281 and 47R5. Let's measure those. I don't think there's going to be a problem with these. What was that, 22 ohms? $47 ohms? That doesn't... 47R5. Gotta do a sanity check here real quick. Alright, 47. So these two are good. 22.4. That's what they're supposed to be. I just read them wrong. I'm getting delusional. Next, let's verify our voltage rails are tracking properly. And I know we did this once already, but we'll just do it again. As volume increases, the voltages should, be proportional to it. We're going to check those by these resistors up here. So 0 millivolts, that's weird. I got 2.9, -3. So interesting, I'm not getting high rail voltages. I wonder if it has to do something with that. I know we checked this before, but 5.2 volts. 6, 11. So I'm at full volume and I'm only getting 11 11 volts out. I wonder if it's a voltage drive issue on the power supply. I never cranked the volume up. Let me again verify that it's not an issue to do with my box. Those voltages should be higher than that, I think. It should be plus, like, up to plus minus 50 volts. But the dashboard is working because we have our 5, so that means the audio tracking isn't working. I might have to go refill my coffee. Alright, let's investigate that really quick. Because if we're not getting our tracking voltages, that could be throwing a lot of things out of whack too. So I'm going to go back to this guy. Known working, somewhat working plate. Who knows what condition it's in now. But I am curious if we're not getting our tracking voltage. If that's the case, then I know a whole different area to investigate. Alright, everything's hooked up. Power. Alright, so maybe this is an issue with my preamp. I mean, it could be the current limit, but I'm not getting I bet you I blew up my preamp. Or something else is going on. But I'm not getting anywhere near full rail voltage. Like, I have 5 volts now. I cranked the volume up. Volume's at full and I'm only at, like, it went into current limit and shut down. But I'm only getting like 12 volts here. Let me put this on full power because this has a heat sink. 6, 8, 12, 15. I'm only getting 15 across the rails. That ain't right. That's not even close. Let's I think I blew up my input. I'll just have to rebuild it. That's not the end of the world, but let's see what we get with this guy. Turn the volume all the way down. It should be much, much higher than that, even with current limited on. So I got 5 in standby. Start cranking the volume up. It's not doing anything. Why? Because it's not plugged in. No, it could be because I'm running it at, you know, pretty stiff load, but this should be able to do 300 watts. I would expect to see more voltage out of these. Maybe no load it would go higher. Alright, 5. Oh yeah, I'm already at 10, 17, 20. Still seems kind of low, but you know, I am hitting it into a pretty hard load. 15. So my output is a little shy for whatever reason. I'm not hitting voltage. I'm going to try using this preamp with the other board. I don't think it's going to make a difference in the audio signal. Actually, I want to just look at that. Let's see what it looks like using my box. Because even at lower levels, it still shouldn't look distorted. The signal going in was pretty clean. Alright, let's we'll look at pin 7. Power is on. I have no audio inputs. Now I do. Alright, let's look at pin 7. Crank it up. Yeah, I mean, that's a nice wave. It's a little bit out of form, but I'm looking at the op amp, not the speaker, so if we go to the speaker terminal, it looks beautiful. But still over here on pin 7, it looks, you know, you can see both halves of the wave. And on pin 1, you see both halves of the wave. So even though I'm getting a little bit less volume output with this one, it's still behaving like it should. If I check the gate of Q11, which is where it connects to Q9, it went way negative, that's not it. Let's see here. So I'm not getting a very clean one. My voltage is kind of high, so I wouldn't expect the signal to be that clean. What's the top of that one go to? That should be the output that drives the MOSFET. Yeah, let's look at the gate at Q14, which is the top pin on Q11. There's our half waveform. That's what it should look like. That's the one half, and then the other half catches over on the top, which is Q12? Q12. I kind of want to look at both of these at the same time just because I'm tired of trying to figure out what the problems are and I need my brain to rest for a minute. Just hold it. So if I do 1 on Q11, oops, I gotta turn channel 2 on. 1 volt, they should be overlapped. I shouldn't need a ground reference for this. This is a cheap scope. It doesn't have isolated grounds. Maybe it... Oh, I'm at 100 millivolts. I screwed up. My bad. Alright. Here's one part of the waveform. And there's the other. So when you overlap them, there's your sine wave. So the device is functioning as it should on this plate. Why is it not functioning on the other plate? It's like the longest diagnostic video ever for such a ridiculously simple problem. And I can't figure out where the heck the problem is. And I hate giving up. I absolutely hate it. Alright, back to this guy here. So we know we can get a waveform out with it. It might not be the prettiest waveform, but we can get a waveform. What do we have to do to make this thing behave? What am I missing? I'm going to retitle this video to the longest simple repair ever. It shouldn't be this hard to get one of these going. Alright, let's turn our volume down, current limit our power, fire it back up, see what we got. As soon as we give it volume, it just goes bonkers. The two components are not being added up properly. So let's go to Q11, see what we got there. There's like some gnarly hashing on there on Q11. I don't know what that is. Q12 is a little bit better. Actually, I know what that hashing is. That hashing is the biasing. Hold the phone. We can dial that out. If I adjust the correct pot. Come on. Lock onto that signal. There we go. Yeah, that's the biasing right there. That I should be able to pull that out, but it's not coming. That's way too high. That's about right where it should be, but there's a gap in there. Let's go back to Q11. This side still looks somewhat decent. It has both halves of the waveform. Q11, Q12. They're both there. They're not like super pretty, but they're both there. Let's see what we got on the positive side. Q17 and Q18. See if I have waveform there or not. Q17. Oops, I'm on channel 2. Man, that one doesn't look too good. It's missing the little dip in the middle. And Q18 is way off in the weeds. So it looks good at low volume when there's like no volume there. When I add more, it starts to freak out. Is it a power related issue? Yeah, I'm at 5 volts. 7. It's almost like the feedback from the dashboard is not allowing it to function properly. Let's take a look at the feedback circuit. I don't think it's a voltage related thing, but who the heck knows at this point. So the audio track goes through R56 and that's the compressor circuit. That's U2. That's not even on this board. That's on the preamp board. Audio track. Here we go. Audio track. We gotta make sure audio track is getting to the control board. Audio track is pin 1. That means R56. I don't think it's a voltage issue, but it very well might be. The audio track is an important part of that. So that's what tells the power supply how much juice it needs for making the output function. U3 pin 9 should have audio track info on it. Let's see what U3 pin 9 looks like. Put the volume down, yeah. It still doesn't explain why. I guess Q14 is still the hottest out of all of them though. I don't get why why Q14 is so hot. Like, I can't even keep my finger on it, and there's no bus voltage going to it. When the volume is down, it shouldn't even get warm. It should be in standby mode. I'm gonna investigate the audio track. I'm gonna check the output of 9 and 14. Make sure we're getting a good waveform there off U3. I think we did this previously in the other video. Let's turn channel 2 off for now. Yeah, we get audio. There's 9. There's 14. So we get audio information coming out of there. That goes to D15 and 16, which rectifies it. Where are those common? Those are common on the top. So we should get a signal here. We do. There's no negative component because we're going through a diode. That's good. And it grows with volume. So we're good up to that page. It looks like it goes through a 2.43K resistor. R56. Maybe R56 is bad. Now the current sense, since Q14 is getting hotter than the rest of them, it's probably drawing excessive current, and that could be what's limiting the rail voltage. So the dashboard is actually protecting the output, which makes sense. I'm gonna check that resistor, and then I gotta go back to focusing on why Q14 is getting so hot. R56. .9. So we shoot 2.43K and 1.9. 1.9 is pretty close. I'll check that on my other board just to make sure it's within reasonable limits. Can't even get a measurement on this one. 1.99K. So yeah, that's pretty much right there. There is a diode in there. We'll check that diode just to make sure that ain't freaking it out. I doubt it, but doesn't hurt to check. This board is like all goobered up. .723 volts, and that was with this on top. So diode's not the issue. I don't think the dashboard's the issue. It brings me back to hot Q4. I gotta look at the gate. The gate comes off of R95. I gotta see what's going on with that gate, and then compare it to R94. Maybe that'll tell us why it's getting hot. Checking the gate with reference to I don't even know if I can measure this like that, honestly. I don't think the gate can't be referenced to common ground. Well, let's see what happens when we measure it anyways. So I'm getting like a 40 hertz signal on there. R95. That's the one I'm just looking at. R94. Looks pretty much the same. Let's look at the output again. Still doesn't look anywhere near like the output should. I am looking at I'm not using audio ground though for that. That could be one of the reasons. Let's let me turn this off. Let's switch my ground. See if I can get this guy loose enough to where I can get the alligator clip and the fast on there. There's not going to be really anyway. These darn insulated terminals. I knew I shouldn't have put these on here. Oh, wait a minute. That might work. Let's try that. We will do ground to speaker minus while carefully trying not to short anything out, and we will go to speaker plus. Yeah, same thing. Just very, very weird and ugly looking. The waveforms aren't being put together. They're missing. It's like these are the little humps. We're actually missing the part of the sine waves that should be combined, and it's combining the humps instead, which is kind of weird. I don't know why. Let's kill that. Go back to basics. The earth ground should be. Here, let me put my alligator clip back on. Where is my alligator clip? Probably buried somewhere. There it is. I don't think it's going to change anything, but it's just for the sake of saying we don't have that capacitive coupling floating. I just want to make sure that doesn't change the way the waveform looks. I don't think it will, but yeah, it doesn't matter. Not it. Not it, not it, not it. Just verify that I didn't do something stupid when I did the caps. Make sure the polarities are right. It's not, I don't think it's the compressor. It's not part of the muting circuits. It's only on the output. We looked at the output of C and D on here, which is the other two pins, and those outputs look good. So coming off the preamp, look at them again just to quintuple check everything. It's a nice waveform. That one there, that one there. So coming up to the actual output amps, it looks good. But the actual outputs don't look good. Let's check pin 1 and 7 again and see which one is misbehaving. I'm going to look at both of these at the same time. Maybe step through this. I wish I could clip these on these tiny little pins. That would be nice. Channel 2. Channel 2 is at 1 volt on pin 7. And I'm getting wave. Pin 1, I'm getting nothing with volume all the way down. I'm gonna step through the resistors. So R97 and R80. Voltage regulators are getting hot too. There's R80. I got nothing. Very low. If I take the load off, let's try and run it no load, see what happens. Should help with the heat a little bit. And I should be able to crank the heck out of it without it getting mad at me. So there's R80, and here's R97. Let's get a little volume. R80. R97. Why are those at different values? Oh, because channel 1 is not the same as channel 2. Channel 1, 1 volt. Now they should be the same. 80, 97. That's before the op amp. They're not directly overlaid, so they're going to look a little weird. Now they should look perfect. So that's good. Going into the op amp is good. But if I go to pin, if I go to R81 and 98, 81 and 98, there's 98. I don't know where 81 is. I was having problems finding that before. that's this one here. Those are those 10Ks. Yeah, it looks the same on the top side. Nicely interleaved waveforms. Now if I go to the op amp side, it's weird. Why do I get only a signal when I touch both of them? Oh, because I'm only getting a signal on the blue line, that's why. So R98, I have something. R89, I got nothing. I have it here. There and there, beautiful. There and there, beautiful. Connection side of R81 to the op amp, totally boned. So it still has something to do with the negative speaker side. If I take out R82, I lose feedback. Even if that goes to speaker minus, it shouldn't matter. Let's see what I have at speaker minus, just for the heck of it. Beautiful sine wave. Go frickin' figure. Oh, I hate this thing. So speaker plus is not looking too hot. Speaker minus is a beautiful sine wave. I don't think that's supposed to be a sine wave, to be honest. I think that's supposed to be a component of it. I'm gonna have to look at the waveform on the yeah, my outputs aren't getting hot now too, which I guess is good. So we can run it just open. Negative, positive. Positive looks pretty ugly. And if I go between negative and positive, yeah, we definitely don't have audio there. I don't know what the hell that is. But if I look between plate ground and negative, that's nice. Plate ground and positive, not nice. Which one's broken? I do not know. Let's switch back to this guy really quick and do a little analysis. Little no load. Alright, this is plugged in. Give me my probe. Beautiful. Beautiful. Alright, so now we're focusing on the positive side, which I can't for the life of anybody say why. So with plate reference, the waveform is exactly the same. I don't think it's out of phase. I guess we can find out by just hooking both. Yeah, they are out of phase. So they should look like two beautiful interleaved signals like they did going into the op amp. So the positive side is not behaving. It's like the longest stream I've ever done. We're learning though, right? That's the important part. I'm talking to myself, and if somebody actually watches this whole thing all the way through, they might learn something. It's good troubleshooting though. I don't know. You know, if nothing else, it helps with figuring out what the heck is going on. So we're almost there, but the speaker plus is crazy. And that's interesting because if I look at the speaker minus on pin 1 going out of the op amp, alright, going out of the op amp on pin 1, I actually have a signal. Maybe having the speaker hooked in screwed us up. So I go to pin 7. Yeah, pin 7 just goes crazy. And it's unstable, so that maybe that trace is broken. Maybe we're not getting feedback. Let me double check that I didn't screw that up by soldering that jumper lead on there. I'm pretty sure that's supposed to be there, but maybe I don't know, maybe I goofed. We'll just verify real quick. No, speaker plus definitely connects to that cap. Speaker minus to the other one. And speaker plus also connects into the resistor network and the outputs. So let's make sure that since we did solder on this thing, it's still behaving. There's no short, no short. This goes to here. We're still going to plate ground. Let's see, maybe it's... don't tell me, son of a bitch is a broken trace. Didn't I say like 2.5 hours ago? Somebody remind me. I think I said like 2.5 hours ago it's going to be like a broken trace. I am not getting a connection from speaker to my resistor here. I got nothing. I bet you. Son of a bitch. Alright. We were chasing the impossible, basically. Chasing the impossible. So let's see if this fixes the problem, and then I'll explain it. I do think having the speaker in helped mask the problem, because we were looking on the negative side and it's actually an issue with the positive side. I guess this is something that anybody could overlook. We'll check continuity to the trace. It's not there. That's sure as shit, that's the problem. Alright, well, I don't feel like a dummy anymore. Because, in my defense, that's a difficult thing for anybody to find. Maybe somebody that understands circuits could find it a little bit faster, but a broken trace, come on. I'm actually going to wire the whole trace. I'll get a piece of magnet wire and I'll just go from the lead all the way across, and instead of just doing a little jump. No, a little jump will be sufficient. If I go on the outside of the board, because there's another trace here that's pretty close. If I go on the outside of the board, I can make it work. I do have to desolder that pad though. Solder sucker is clogged. Alright. Here we go. Let's make this thing work. I don't know why I didn't find that earlier. It's kind of maddening. But I wasn't exactly looking for it either, so. What I'm doing right now is I'm just making a jumper that's going to clip onto the leg with the fast on, and then it'll connect into the trace. It needs an offset, so what I think I'm going to do is I'm going to solder it in, and then I'll put the zigzag in, and then I'll trim it after I'm done. think I know how to fix my other plate that was having this issue. And I bet you it comes down to a darn trace that is going to end up being loose. I 100% blame the way that this was manufactured for this defect too. There's no logical reason why those traces need to be that thin. None. They're on a terminal that's going to vibrate. They connect to the pad in a very, very small spot. I don't want to say it's a design flaw, I just think it's maybe an oversight. I don't know how you describe it, but it's totally unnecessary to have these traces this small. So what I'm doing right now is I'm just guiding the lead to follow the path of the original trace. So I'm putting like bends and zigzags in it. I want it to lay right on top of the original. I don't want it to be too close to the other one where it risks shorting. It's a little bit beefier wire than we need, but I also want to make sure that it doesn't vibrate loose again, because how annoying is that? Just missing feedback from the op amp, or to the op amp, and it's caused the whole thing to go crazy, and it was all due to a broken trace. It all boils down to a broken trace. Well, let's check it now. We're going to go from the fast on to our 2 resistors on the board. Alright. It's going to work. I know it's going to work. And it's going to be super exciting and annoying at the same time. Shine up the board a little bit. Alright, make sure we get all the crap out of the way. I don't think we need that ground on there. To be honest, I don't think it matters. And we're going to find out right now if it does or doesn't. Alright. Make sure everything is safe-ish. Let's power on. Volume's down. Scope's still on. There we go. Let's look at speaker negative, because that one was working. There's negative. There's positive. Son of a bitch. Let's overlap them. There it is. Q14 will no longer be getting crazy hot. I should be able to kick this up and we'll get really good amplitude now. A broken trace led us on this wild goose chase for that long. So here, I'll show everybody what the heck happened. I think plugging the speaker in one had us kind of thrown off, but so there's, let me zoom in just a little bit. Where's my remote? It's early in the morning, I know it's late. Alright. So there, the audio signal comes in here and it goes to this op amp. Then it goes into the circuit here and it splits in two directions. These two transistors are biased by the plus minus 15 volt supply, and that shifts the waveform, basically the waveform intensity up or down. These two diodes change it into the either positive or negative humps, and then they get combined at the outputs. But in order for this op amp to function, it needs feedback. So that trace being broken didn't allow the speaker plus, which is this connector right on the board where the speaker plugs in, it didn't allow the feedback to go to the op amp. So if the op amp doesn't have feedback, it freaks out and it doesn't know what to do. So that's why the signal was getting screwed up. So two things I guess we learned out of this crazy video. Number one is when you're troubleshooting an audio issue, do it without a speaker attached. And number two, these traces oops, we gotta zoom out. The traces that are going to these speaker terminals here are very delicate. So if you you know, have vibrations or you know, abuse these things or bend them, you risk cracking the trace and then you lose your feedback. And if you don't have feedback going to the, and both of these provide feedback to the op amp. So if you lose your feedback lines, you're going to have issues. And I think that the plate grounds, like that has to do with noise somehow. It like running them through the capacitors, it has to do something with noise. So you know, those have those little traces too. So I guess, you know, if you're having audio issues, you need to check and make sure that your speaker terminals are making their connections back to the op amp. I would start there versus blindingly replacing components. Like, you know, I never suspected that until like I just finally figured it out. So hopefully this will save somebody a ton of time trying to diagnose this. Now, since I did mess around with these pots, the bias needs to be adjusted on this. I don't know how far out of whack it's going to be by hooking the silent speaker in. We can take a look at it though. Since I have the scope and everything just like sitting here already, we can try. It might be it might be no good because I might have to have this on a heat sink because I'm gonna have to turn the volume up, you know, to a fairly decent level to actually see the distortion. I guess I can do it in short bursts. And actually it's like spot on. Let me take it out of whack. And I can at least show what to look for. Where's my little adjuster at? Oh, what an adventure. This was an adventure. I do it at 100 Hertz too. I gotta turn my frequency up. I don't know if there's a right or wrong frequency to do this at. This is just the one where I do it. So you gotta kind of do it, or I gotta kind of do it quickly. And I'm gonna zoom way in on the waveform and way in on the time. So I'm looking at this section. Let's turn channel 2 off. I'm looking at the section in between the two peaks and valleys. Maybe that's a little bit too fast. You got to get it to a point where the scope is happy too. I don't know if I have the trigger on rising edge or where it is. It is on rising edge. Keep hitting the wrong button here. I want I want it on auto because I want it to scroll. This thing's starting to heat up. I gotta turn it down for a second. Run. Volume. Alright, so we're gonna look right in there on the wave, so let me whack it out. It's not going on a phase. It could be because I have it hooked into a resistive load, not a speaker. I'm normally I do not see any distortion. I don't want to get this thing too hot and blow up an output. I am running current limited right now too, so that could affect it. Well, I'll tell you what. I'll go over the bias tomorrow. I want to get this thing back on the plate. I want to get the heatsink on it so I can actually put some juice into it, crank this thing up, and I'll go over doing the bias, and we'll do it with the speaker hooked up because that's the way I normally do it. I don't do it with the resistor. So yikes! It's been an adventure tonight. We're chasing an issue, and you know, like, it happens. You know, like you got to be prepared for this. No matter what you do, you're gonna run into sometimes, you know, these anomalies and problems troubleshooting where you're not going to be able to find out what's going on. And you know, a broken trace is a tough one. I really don't know what else to say there. It's not easy to find. It's almost impossible to see. The board had 2 broken traces on it. Maybe, you know, after checking the first one, I probably should have checked the second one, but I didn't think about it. So, you know, I assumed everything else was the issue, and it just ended up being a bad trace. So, you know, I hope to save somebody some time. I'm gonna put in the comments, like, you know, watch the last 30 minutes of the video, because it basically, you know, we went down this rabbit hole and we really didn't need to do so. But I'm gonna call it a night. It's pretty late. Thanks for tuning in. Like and subscribe, and we'll do some more videos tomorrow, and I'll get this put back together, and I'll just make a little short clip on how to do the bias on this. I think I've done it before. I'll double check if I have that video. If it's posted, I'll link it. If not, then I'll just do another video, like a little short clip on how to do that. So thanks for tuning in. We got another amp saved, and